Okay, so now we want to write the formula ourselves based on the pattern that they give us. So you'll notice that A and B are both infinite sequences. These are infinite. I think there's a C, but I think it's infinite also. But they're infinite sequences. Now, you look at the first one and you're looking for patterns. I would look to see if it's an alternating sequence first. Okay, so this is alternating and it starts out negative. So if you remember, that's going to be like -1 to some nth power. So that'll give me negative, positive, negative, positive. It's going to do that type of thing. Then if you have a fraction, you generally you look for a pattern in the numerator and a pattern in the denominator. Okay, so look at the numerator. See how it's going. I'll do this in orange. See how it's going 2, 3, 4, 5, 6. Now if you're saying, no, it's -2, +3, don't worry about the sign because we already took care of that. So we just want to get a 2, 3, 4, 5, 6. Well, how do you do that? This is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. So do you see how the numerator is just 1 more than n? So n plus 1, that'll do it. Okay, so that's the numerator. Now we have to look at the denominator and see how we can get that. 11, 13, 15, 17, 19. Looks like those are odd numbers, but they start at 11. So there's a couple ways you can do this, but in my mind, when I saw it, I was like, okay, so I'm starting with 10 and I'm adding 1. Then I'm starting with 10 and adding 3, right? Because this one right here would be 10 plus 3, this would be 10 plus 5, and so on. That would do it, right? But how am I going to get this to be an odd number? Even numbers, okay, so I want to write this someplace so you'll have this in your notes. Even numbers can be generated by 2n, right? You put in a 1 and you're going to get 2. You put in a 2, you get 4. You put in a 3, you get 6, and so on. That'll get you the even numbers. But the odd numbers, so odd numbers, those are generated by 2n minus 1. So you take the even numbers and then subtract 1 from all of them, and you're going to get 1, 3, 5, etc. So I was thinking I need 10 plus 2n minus 1, which that winds up being, if I combine the 10 and the -1, that's going to be 9 plus 2n. So that's the answer right there. That's how I'm getting each term. That one was a little complicated because we had to talk about how to get the numerator and then how to get the denominator. They probably would write the denominator 2n plus 9, but I'm not going to worry about that. It's addition, it's commutative. Okay, so let's go over to this one. So you'll notice that they're all negative. Negative, negative, negative. Okay, so that's great. We just know it's going to be negative. You don't have to put in a -1 to any power. It's just going to be negative. And look at the numerators. They're all 2's. Those are constant. So the numerator is 2. Okay, the denominator, though, that's changing. So you have 25, 125, 625. Do you see a pattern? It's 5 squared, 5 cubed, 5 to the 4th. Now you could check, I'm going to guess 3,125 is 5 to the 5th, but you could check it on a calculator if you had any doubts. Usually if you have 3 numbers, that's enough to establish the pattern, but I'll check it out on my calculator. Yep, 3,125. Okay, so you see a pattern here. So I'm going to have a base of 5. That's always constant, so 5. But not to the nth. Remember, it's this was the first term, so n is 1. So it's got to be, and this is the second term. So I'm going to be n plus 1. Okay, so now that all looks messy, but that's what I get. So the formula is a sub n equals -2 over 5 to the n plus 1. Now, you should always check these and see if you're getting the terms. So, you could do that. You say a sub 1 is negative 2 over 5 to the 1 plus 1, which is negative 2 over 5 squared. Yeah, that's going to be the first term. And then you do the second term, and you do the third term, and you do a few terms just to make sure that you're getting the pattern. But, yep, the answer is right here. That's the formula right there. Okay, so we've got one more. This one I thought was the easiest one. So you look at your pattern. It's not alternating. It's not negative, so you don't have to worry about that. It's positive. What's really changing? Well, you have a 4, then you have a 5, then you have a 6, then you have a 7, then you have an 8. So what is that? This is when it's the first term. This is when it's the second term, third term, fourth term. Okay. Anyway, so on and so forth. Well, it's always 3 more. See, 1 plus 3, that gets me 4. 2 plus 3, that's getting me 5. 3 plus 3 gets me the 6. Okay, so that's how we're getting the 4, the 5, the 6. So the 3 is constant, but this is n. So it's n plus 3 to get those exponents. So the exponent is n plus 3. But how are we going to generate this? This is going to be a sub n equals e, the e was constant, to the n plus 3. And so that one's done. And you could check it by plugging in the numbers. See, you'd have a sub 1 would be e to the 4th. And a sub 2 would be 2 plus 3, which is e to the 5th. And so on and so forth. Okay. Sometimes it's hard to find the patterns. Sometimes you'll see them right off.